Okay, this video is going to talk about how to find wholes of rational functions and what it means to be a whole. Okay, so we're going to start with this rational function for a moment. And I'm going to think about this for a second as a little bit different. I'm going to write it this way because I think it'll help us to understand the idea of a whole. Now, hopefully everybody sees that these two things are actually the same because when you multiply fractions together, you multiply the tops and the bottoms. So this and this are actually the same thing, right? Well, when we think about this little fraction here, hopefully everybody sees that it's x plus 1 over x plus 1, and anything over itself is actually equal to 1, right? So this is like saying 1 over x plus 3 times 1, which is really equal to what? 1 over x plus 3, because anything times 1 is equal to itself. So in this case, this is this function times 1 would give us itself. And I'm actually going to call this one for a moment just to make it a little easier. We'll call this f of x, and I'll call this one g of x, because although they're very similar, they're actually not quite the same thing. So this function and this function, we know have to have some similarities at least, right? Because we just said when you multiply by 1, it doesn't change anything. But if you remember when we've been talking about our excluded values, right, we always say that we have to go back to the original thing that we were talking about when we talk about our excluded values. So the excluded values here are x cannot equal -3 and x cannot equal -1, right? Those are my excluded. But excluded here, well, that's only the -3, right? X cannot equal -3. So this and this is not exactly the same. It's just very, very similar, okay? They're like twins. And what does this mean for our picture? Well, let's take a look at the graph on the calculator first, and then we'll draw it out so you can see what I'm talking about. So I'm just going to get my calculator out here. And what I'm going to do is I'm going to draw both of these graphs. The first one is this one. So I'm going to put in I'm going to use my parentheses, of course, because if you don't use parentheses here, you're going to get the wrong answer. So the bottom needs to be, not only each of these need to be in parentheses, but the whole bottom needs to be in parentheses so that it will do that, together. So I'm going to do x plus 3, and I'm going to do x plus 1. And for function 2, so can you see that? So I did x plus 1, over this thing, this denominator. Okay, the second one, I'm just going to do this one, 1 over x plus 3. So 1 divided by x plus 3. Now, if these are actually the same thing, what would that mean for their graphs? Like if you graph the same function, like think about it when you're doing your lines, right? What are a couple things that could happen? You could have lines that intersect like this, right? Or you could have lines that are parallel and they sit next to each other like this. Or you could have lines that sit on top of each other like this, right? And what does that mean? It means that this one means their equations are actually the same thing. So when the equations are actually the same thing, what it means is that these graphs should be sitting on top of each other. So let's take a look. I'm going to hit my graph button. Here it is. It's graphing the first one. Now it's graphing the second one. And you can see that on the graph, they look identical. They look like the same picture. But there's one thing that's very, very different about them. So let's go to the table to see if we can see that thing that's different. So I'm going to clear out these things so we don't have to look at those. Okay, you ready? Now I'm going to put in some values for x. So I'm going to put in a -1. And what should we see here? This first one, it says error, and what does that mean? And remember, this one is y sub 1 in my calculator because I typed it under y sub 1, and this one is y sub 2. So when you're looking at these columns, that's the y value for the first function, the y value for the second function that I typed in, which this one was the first one and this one was the second one. So the first one says error, and why? Well, we just said -1 was an excluded value, didn't we? But this guy actually doesn't come up with an error. He says that it's a half. Now let's put in -3. This time, since it's excluded for both of them, they both say error. But take a look at what happens when I put in any other number. Let's put in numbers close to -3, like -2.9. Exactly the same. -2.99. Exactly the same. Do you see what happens here? All the other values, if I put in any other value other than those two, they're going to come out identical. And actually, they come out identical for -3 also, right? The only one, and I could do this all day, I could type in 100,000 of these, but obviously we don't have time for that. The only one that's going to come out different is this -1. So what does that mean is these two are graphing right on top of each other. The only time that they don't look the same is right at -1. Okay? Now, why do they look exactly the same on my calculator, but they're not exactly the same? Is because let's think about this. Let's go back to our geometry skills. How big is a point? How big is a point, right? Well, think about this. If you don't know the answer to that, how thick is a line? Well, if you remember in geometry, we draw lines like this, right? But actually, lines aren't even as thick as this pen mark. That just represents a line. But lines actually have no thickness, right? So they have no thickness in geometry, right? So when we talk about a line, we're talking about something that actually doesn't exist. Like if I could, look at him, if I could pick up the paper and look at him the other way, right? This pen mark doesn't have any thickness this way. Think about that. It also doesn't have any thickness this way, but I can't draw a line that has no thickness that way. So we draw it as a line. A point is the same thing, right? So a point we draw like this, but that's actually way bigger than a point. A point we wouldn't be able to see it. It has absolutely no thickness, no height, no depth. So it's actually something we can't really draw. So we use this to represent it. So on my calculator, what's happening is it's making a little space at -1 for this one, but it actually doesn't show up on the graph because that space actually doesn't have any size. So your calculator doesn't know how to represent it. Okay? But we know how to represent it. So what we're going to do first is we're going to look at a couple of these and see how we figure out how to find a hole, and then we'll graph some with a hole. Okay? Now maybe you noticed that what was important here was this little piece simplified to 1. That's actually what made the hole. It says I can't actually use -1, but really it's kind of like multiplying by a 1. So if a function has a hole, so if a rational function has a hole, then I should be able to reduce, I don't know what word you like to use, cancel the factors on top and bottom to get 1. So what do I mean by that? I mean just like this. See how this factor and this factor, when I set them on top of each other, they give me a 1? If that ends up happening, what you're going to be doing is creating a hole in a function. So let's look at a couple of them. We'll find the holes, and then probably in the next video, what we'll do is we will actually graph some functions that have holes so you can see what we can do here. Now this one's not as clear as this one because these ones were already in factored form. Okay, so what I'm going to do first, in order to figure out if I will be able to reduce it, I'm going to factor both the top and the bottom. So what am I going to do here? Here I can factor out an x, and that gives me an x squared minus 1. And on the bottom, I can also factor out an x. I hope you can see that. So that will be an x squared minus 4x plus 3. But these actually can still be factored. I don't know if you can see that. So you know what I'm going to do? I'm going to call this one f of x2. Okay, just because later I'm going to use another symbol to represent his twin. Okay, so let's factor some more. So it would be x, x plus 1, x minus 1, because of course this is a difference of squares. So he factors into x plus 1, x minus 1. All right. Now we have x on the bottom. Let's see if this thing factors, and hopefully it will. I know that it has to be a 3 and a 1 if it's going to factor. And I would need them both to be negative, which kind of makes sense here. So that looks good. So this is my f of x, okay? Now let's talk about our excluded values quickly. So my excluded, so hopefully you see that my excluded values here, this one says that x can't be equal to 0. And again, how do you find excluded values? You figure out what makes this denominator 0. So if that were 0, that would be no good. So we have to exclude 0. The number that would make this factor come out to be a 0 is a 1. And the number that would make this factor come out to be a 0 would be a 3. So we have to exclude all of these values, okay? Now those values, if you remember from previous videos, they're either going to create vertical asymptotes. We said that's one way to get vertical asymptotes, or they're going to create a hole, okay? So these places will have a hole or an asymptote, okay? A vertical asymptote. All right, so let's take a look at which ones these are. Now, again, you probably don't have to rewrite these, but I'm going to rewrite it like this, just because it's easier to see. Okay, so do you see I put this over this, this over this, and this over this. And that would be the same exact thing, because when I multiply all these together, I'd get that top, and when I multiply all these together, I'd get that denominator, right? So again, this one would reduce to a 1, this one would reduce to a 1, but this one would not reduce to a 1. So what can we say here now? We can say that there is going to be a hole at x is equal to, well, what would make this thing undefined? That was the 0. And x is equal to, well, that one was the 1. But this is the guy that's creating the vertical asymptote. So the vertical asymptote is going to be x is equal to 3. Okay? All right, so that tells us the x value of the hole. But since the hole is just one little point, and he's not a line like the asymptote makes the line, so if you look at this example again, you see that the asymptote is the thing that makes this, the line would be this vertical line, but the hole is just that little hole at -1, I think it was, right? So it's just a little pinprick in the graph right here at -1. And if you take a look at the table, it said that it was error for this one, and for this one it came out to be 0.5. And this is an important thing. So let's think about this. Let's look at this graph again for a second. Since this, imagine these are two graphs sitting right on top of each other. So let me draw them on the back side of this so we can see what I'm talking about. So what we actually have here is a graph. I think it was -3 was my asymptote. And then at -1, we had a little hole for one of them, and not a hole for the other one. So this is my 1 over, for this example, it was x plus 3, right? So this is my example of 1 over x plus 3. Okay. Now this other guy, he has a little hole here, but then he does all the same stuff. So he's sitting on top. And this green one is the original one that we were working with. Okay. So what's true about here is, let's take a look. If the hole has to be here at -1, and the green and the brown have to be sitting right on top of each other, what does that mean? It means that they have to both be getting close to that same value at that moment in time. And the green one's going to do a tiny little hop and then come back down, and the brown one's going to go right through. So in order to figure out the height of this hole, what I want to know is, what is the value? What is the y value of the brown one at x is equal to -1? That will tell me the y value of this hole. Does that make sense? So the y value of this green one will give me the y value of the hole. And the reason why I'm not using this one is because I can't stick a -1 into this function. It gives me no value. won't be able to figure it out. But this guy who's his twin, it's like having a twin that has like a little freckle right there, right? His little freckle, or this guy, I don't know which one has the freckle, the one with the hole or the one without, right? But this guy has a little opening right there, but this guy goes right through that point, but they're doing it at the same time. So when he has a hole, he's having a value at -1. And whatever that value is, that's the y value for both of them, right? The y value at -1 is going to be whatever it is, and that's going to give you the y value of the hole here, because they have to be doing the exact same thing every other time. They have to look identical. So what did we say happens? How did you find it? Well, all I have to do is plug in a -1 here. So this one we call g of x, I guess. So if I do g of -1 is equal to 1 over -1 plus 3, we already knew that it was going to come out to be a 1/2 because we saw that on the calculator, right? So this guy's hole, so the green hole, or the one for f of x, right, is going to be happening at 1/2 comma -1. That's his hole. Okay? So how did I figure it out? I just used his twin to trick it into being able to put in the -1 because I know I can't put -1 into this one. So then let's go back to this guy. If I want to know what the hole is, well, what I'm going to do is I'm going to use his twin function, and his twin happens to be this one. Now, the only thing different about this function and my original function, right, is that these guys have 2 holes and this guy has no holes. But everything else about them is going to look the same. Okay, so how do I find the hole? Well, we already said the x values are 0 and 1. And if I want to find y values of a function, what do? I plug in the x values. So in order to find the dependent variable, I plug in the independent variable. So what do I need to know? I need to know what g of 0 is. And what does that mean? It means put in a 0 everywhere I see x. So that's a -1/3. And then I want to find g of 1. So that's going to be 1 plus 1 over 1 minus 3. So that's going to be a 2 over a -2. Is that true? Yeah. So that's a -1. So where are my 2 holes? My holes are at, well, 0, comma, -1/3 and -1, comma, 1. These are my holes. Okay? What do you think? We'll do one more, and then let me get another piece of paper. We'll do one more. So let's say my f of x is, I don't know, x minus 2 over 2x squared plus 2x minus 12. Okay. So the first thing you got to do when you're finding holes, number 1, is to factor them to see if there are any factors that are going to reduce to a 1. So that means I got to factor this denominator. Okay, so let's do that first. The top is, there's nothing to factor. It's as factored as it's going to get. So first I'm going to factor out the 2 to make this a little bit easier to factor. So does everyone see that I just factored out the 2? So this is still f of x. And now I'm going to factor this if possible, and I think it is. I know that it's going to be, what, a 2 and a 3? And I want the 2 to be the negative. And so now we see, again, now we see, you can either rewrite them, but hopefully everybody can see that this one right here are going to be the ones that we would like cancel out, right? If you want to use that word. They're going to reduce to give you a 1. So that means my g of x, his twin function that looks the same as him and is almost the same but not quite, is actually this guy. Does that make sense so far? All right, so this one is going to produce a vertical asymptote. So my vertical asymptote is going to be x is equal to -3. So this leftover guy that does not factor creates a vertical asymptote. And this guy that factored, he's going to create a hole. Now the only thing that I need to do is to figure out where that hole is. And how am I going to do that? Well, the first thing is to figure out the x value. So the x value here is going to be x is equal to 2 will be where my hole is. Okay, and how do I figure out the y value that matches that? Well, I plug it into this twin guy that's doing exactly the same thing as my other one and figure it out. So I'm going to plug a 2 into here. And so I get 1 over 2 times 5, or in other words, 1/10. So my whole is the ordered pair 2, 1/10. That's where the whole would be. Okay? So how do you find a whole? Look for factors that are on both top and the bottom that you can rewrite as a 1. Cancel them out and use the twin function to plug in those excluded values that you canceled out. Make sense? All right, let me know if you have any questions.